Graphing quadratics. What does the parent quadratic function look like? Y equals x squared. Well, when we graph a function, we need a table of values. So here we have some x values. We need to determine the y values. We can substitute the x into the equation to get the y's. But a more efficient and more accurate way would be to use our graphing calculator. So let's go into y equals and type in y equals x squared. We can take a peek-see at the graph. And to graph that, we need the table of values. So hit second table. And here we have the y values that go with the x values. So go ahead and find the y values and graph y equals x squared. This graph is called a parabola. It's U-shaped, and we get that with the x squared equations. It also has an axis of symmetry. That's a line that separates the parabola into two symmetric parts. The line of symmetry and the x value of the vertex are the same because the line of symmetry goes through the vertex. The vertex is the lowest or highest point on the parabola. In this instance, the graph falls and then rises. So the vertex is a minimum, or the lowest point on the parabola. So graph the equations below, then state the domain and range. So use your graphing calculator to determine the y values so that it would be quicker and more accurate when you graph. Number 1, number 2, number 3, and here's number 4. What did you notice regarding the domain of the parabolas? What did you notice regarding the range of parabolas? So how do you graph a quadratic equation in standard form? Y equals ax squared plus bx plus c is standard form. We have 3 steps. We're going to find the x-axis of symmetry, find the vertex, and make a table. We're going to find the axis of symmetry by plugging in the formula that x is equal to negative b divided by 2a. We're going to then find the vertex using our calculator. We're going to graph the equation into y equals, trace to find the y value that goes with this x value. And then we're going to make a table so we can graph. So let's do one together. So first thing we want to do, I'm going to go ahead and put in x squared minus 2x minus 3. So there's my graph. I need to find the vertex here. So I need to know what x value is. I can eyeball it, but let's be sure what the x value is, what the line of symmetry is. So we're going to substitute negative b over 2a into it. All right, our b is negative 2, so we have a negative 2 over 2 times a. 2 times a is 1, is 2, so 2 over 2 is 1. So my axis of symmetry is the line x equals 1. So I know that 1 is my x value on my vertex. So if I go back into my calculator and hit trace and type 1, enter, 1 negative 4 is my vertex. I could also have found that by plugging in, putting negative 1 for x into the equation. So negative 1 negative 4 is my vertex. And I'm going to use a table of value now to graph the points. So to find the corresponding y, I'm going to go ahead and look at my table on my calculator. So graph number 2. graph number 3. How can a graph be used to identify the solutions of a quadratic equation? The solutions of a quadratic equation are the x-intercepts, or where the graph touches the x-axis. In this instance, we have two solutions. We have the solution is 0 and a solution is 4. So now we're going to solve by graphing and find the solutions. So we need to set each equation to 0. The equation has to be set to 0. So in this instance, x squared plus 5x equals -6. We need to add 6 to both sides, find our vertex, and plot some points. And then find the solutions where the graph touches the x-axis. Our solutions are -3 and 2. We can also see -3, 0 and -2, 0 are on our table of values. Solve by graphing. Find the solutions. Remember to set the equation to 0. Our solution here is 1. The vertex is the solution. The graph only touches the x-axis in one spot. Solve by graphing. Find the solutions. Okay, the solution here is there are no solution. There is no solution because the graph never touches the x-axis. So no solution. And number 4, find the zeros of f of x equals 4x squared minus 4x plus 1. And that's the same thing, just in a different format. Instead of writing y equals, we wrote f of x. And the zeros, or where y is 0, that's just another word for solutions or x-intercepts. And here again, we only have one solution because the vertex is the point of intersection, and 1/2 0 is our solution.